Hi, this is Mrs. Rodriguez, your pre-algebra teacher. This video is a review for the Chapter 13 test that's coming up. These questions are from a practice test that can be found on page 853 of your textbook, okay? What I recommend that you do is that when the problem comes up on your screen, go ahead and pause the video, try to solve the problem yourself, and then listen to the explanation. If you get the answer correct, great, move on to the next problem. If you got the answer wrong, hopefully you can figure out your mistake based on my explanation. But if you get to the end of the video and there's still some problems that you don't understand my explanation, please call, text, email, or stop by my office hours and I'll be happy to help you. Okay? All right, let's go ahead and get started. So this is a review for the Chapter 13 test. And Chapter 13 talks about data, right, and different ways to display data. So it talks about the measures of central tendencies, and those describe the center of the data. The most common measures are the mean, the median, and the mode, okay? So it says to find the mean, median, and mode for the following sets of data, round to the nearest hundredth if necessary. Okay, so first thing you want to do when asked for the mean, median, mode of a set of data is put the data in order if it hasn't already been put in order from least to greatest, okay? So looking at the data, I can see my lowest value is 7, and I would cross each set of data off as you go through so that you know you account for each data set, okay? And then there's a couple of 8s. And there's a 9, and a 10, and an 11. Okay, so now I know there's 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So now for the mean, in order to find the mean, you need to add up all the data and then divide by the number of data, okay? So here I would add 7 and 7 and 7, 8 and 8, 9, 10, and 11. And there are 8 pieces of data, so I'm dividing by 8. So that would be 67 over 8. And then that ends up being 8 and 375 thousandths. And it says to round to the nearest hundred. So there's a 7. So in the thousandths place, there's a 5, so that would round the 7 up to an 8. Okay, so this is the 8 and 38 hundredths, okay? And that would be the value of my mean, okay? The median is the middle value when the data is in order from least to greatest. So there's 8 sets of data, so there isn't going to be an exact middle value. You're going to have, the middle is right here where you have 4 pieces of data on the lower set of data and 4 pieces of data on the upper set of data. But the nice thing is they're both 8, so if obviously the average of 8 and 8 is 8, okay? So the median is going to be 8. If the values were different, you would just add them and divide by 2, okay? And then the mode is a set of data that occurs most often. So I can see I have 3 7s here, only 2 8s, okay? Remember, it's not the set of data that occurs more than once, but the most often. So 7 occurs the most often, so the mode is just 7, okay? All right, and then the next couple sections talk about data displays and measures of variation. So it talks about stem and leaf plot. The interquartile range is the range of the middle half of a set of data. And it talks about box and whisker plot, and that separates the data into 4 parts. And then also histograms, those display data that have been organized into equal intervals. All right, so here it says use the table that shows Ms. Fernandez's first period test scores. Display the data in the stem and leaf plot. Okay, so first, what I would do is I have my stem and I have my leaf, right? So the stem is the first digit. So I can see I have values in my 60s, my 70s, 80s, and 90s, okay? So my stems are going to be 6, 7, 8, and 9, okay? And then I would take each set of data and add it into my stem and leaf plot. So I've got 77, so that would go here, 7 and then 7, and then 78, so put an 8 here, 88 would go here, 89 would go here, 67 would go here, 65 would go here, 87 here, 99 here, 93 and 92 would be here, 76, 79, 70, 85, 83, and 81. So that way I know I accounted for each set of data. Now in a stem and leaf plot, your leaves need to be in order from least to greatest, okay? So I have my stems 6, 7, 8, and 9. So the leaf is 5 and 7. I'm putting them in order from least to greatest. And then over here I've got 0, 6, 7, 8, 9. So 6, 7, 8, and 9. And then in the 80s I've got 81, 83, 85, and 87, 88, and 89. So 7, 8, and 9. And then in my 90s, I've got 92, 93, and 99. Okay? And then my should always have a key here. So like 65 or 6 slash 5 is equal to 65. Okay? So there's my stem and leaf plot. Okay? So then question C says, in which interval do most of the grades occur? So you can see from here, looking at my stem and leaf plot that I just made, there's 1, 2, 3, 4, 5 values in the 70s, and 1, 2, 3, 4, 5, 6 values in the 80s. So from 80 to 89 would be the most values. Okay, so that would be the interval there. Okay. All right, now here, this set of data says to display the following data in a box and whisker plot. Okay, so the first thing I'm going to do is put this data in order from least to greatest. So I have a 13, and then I have a 14, and a 15, and then 17 and 18. I have a 19 and a 20, 21, 26, and 29. Okay, so then for a box and whisker plot, I need the median, right? The middle value. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of data. Okay, so I don't have an exact middle value. I'm going to have 5 pieces of data on the lower end, and then 5 pieces of data on the upper end. So my median is going to be 18 and 19 divided by 2, the average of those two, which would be 18 and a half, okay? And then my lower quartile is the middle of the lower half of the data. So there's 5 sets of data, so the third one would be the lower quartile, and then the upper quartile would be the third set of data in the upper part of the data. So then that would be 21. Okay, so when I make my box and whisker plot, I start off with a number line, and my lowest value is going to be at 13. Highest value is going to be at 29. Okay, So I have 13, 14, 15, 20, 21, 22, 23, 24, 26, 27, 28, 29. Let me just put the 29 there. So this is 29. Draw this line again. Okay. All right. So then I'm just going to put every other value here: 13, 15, 17, 19, 21, 23, 25, and 27. So then I'm going to plot my points. So the lowest value is 13. The highest value is 29. My median I figured out was 18 and a half. So that's halfway between 18 and 19. So that'd be about here. And then my lower quartile is 15. Upper quartile is 21. Okay. So then I would put a box connecting my upper and lower quartiles, put a line through my median, and then I put my whiskers here, extending from the lowest to the highest value. Okay, so that is my box and whisker plot. Okay, all right, and then this question, question 7 says, what percent of the data shown above, or in this case to the right, is below 21, okay? Below 21. So here is 21, right there. So each one of these has 25% of the data. So there's 25% here, 25% here, and 25% here. So all three of those together would be 75% of the data. Okay. All right. So here this says to display the data in a histogram. Okay. So in order to display our data in a histogram, we're going to first set it up. We have our X and Y axis here. And this is about time. So time is over here on our X axis. And then we've got intervals here. So first interval is from 0 to 14. And then we've got from 15 to 29. And then 30 to 44. And then 45 to 59. Okay. And then we're going to set up the frequency over here. So it goes up to 12. So I'm going to go by twos. 2, 4, 6, 8, 10, and 12. So this is the frequency. Okay. All right. And then you're going to make your bars here, right? So according to the frequency. So from 0 to 14 minutes, there's a frequency of 12. So that means I'm going to make a bar up to 12, right? And then from 15 to 29, there's 7. So that's halfway between 6 and 8. Okay. And then 30 to 44, there's 4. That's here. And then 45 to 59 is 2. That's here. Okay. And this is the length of time spent reading. So obviously the higher the value, the less people that read so much, right? All right, and then there is your histogram. Okay. All right, so then The next few sections talk about probability, and it says simple probability and probability of compound events. So the probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. When the outcome of one event does not affect the outcome of the second event, these are called independent events. And when the outcome of one event does affect the outcome of the second event, these are called dependent events. All right, so it says a bowl contains 8 red apples, 4 green apples, and 8 yellow apples. Suppose one apple is selected at random. Find each probability as a fraction. Okay, and so it's asking us to find the probability of getting a green apple. Okay, so we can see that there are 4 green apples total. Okay, so there's 4 green apples total out of a total, so that would be a favorable outcome if we selected one of those 4. Out of a total of how many apples? Well, there's 8 red, 4 green, and 8 yellow. So if we add all that together, that would be 20. So 4 green apples out of a total of 20 apples. Now we can simplify that by dividing by 4 over 4, and we would get 1/5, okay, which is our probability. Okay. So then the last section is talk about the counting outcomes and permutations and combinations. So the fundamental counting principle states that an event M followed by an event N can occur in M times N ways. If event M occurs in M ways, an event N occurs in N ways. So and also with permutations, order is important, and with combinations, order is not important. Okay. All right. So here it says find the number of possible outcomes for a choice of bologna, salami, or ham, and rye, wheat, or sourdough, or white bread. Okay, so it wants you to set up a. So we've got the meat, the type of meat, and then the type of bread. Okay. So we've got 3 different types of meat: bologna, salami, and ham. So I've got bologna, salami, and ham. Okay, and then for each one of those, the bologna can have either rye, wheat, sourdough, or white bread. So rye, wheat, sourdough, or white bread. And I would do that for each of these because the salami can also have rye, wheat, sourdough, or white bread. Okay, and the same as the ham can be on rye, wheat, sourdough, or white bread. Okay, so then I would put these lines. So bologna can have rye, wheat, sourdough, or white bread. Same with salami, and same with the ham. So I end up with a total of 12 total outcomes. I also could have done 3 times 4 because there's 3 meat options and 4 bread options, and then that also equals 12. So there's 12 total outcomes, so that would be H. Okay. All right, and then number 15 says tell whether each situation is a permutation or a combination themselves. So it says a number of ways 6 notebooks can be arranged on a bookshelf. So this is where order matters. So this would be a permutation. And we would use the fundamental counting principle to figure out how many different ways these 6 notebooks can be arranged. and that principle is on page 833 of your textbook. So what we would do, there's 6 total notebooks, so we're going to multiply 6 times 5 times 4 times 3 times 2 times 1, and that ends up being 720. So there are 720 permutations or different ways we can arrange those 6 notebooks on a shelf. Okay? All right, and then number 16 says an envelope contains 12 different names. The number of ways you can choose 3 of the names. Okay? Now here you're just choosing the same 3 names. So let's say you have Mary, Joe, and Tom. Well, it doesn't matter if you have Tom, Joe, and Mary, that's still the same 3 names. So order does not matter. So this would be a combination so we're using the combination here of 12. There's 12 total, 12 different names, and we're choosing 3 of them. Okay. So since we're choosing 3, we would multiply 12 times 11 times 10. First time you pick, there's 12 names, then there's 11 names. The third time, there's 10 names. Okay. And then our denominator is 3 times 2 times 1, which ends up being 1,320 over 6. When you simplify that, you get 220 combinations. So there's 220 combinations. Okay. All right. And then here it talks about the probability. It says a card is randomly drawn from the cards shown and not replaced. Okay. The second card is drawn. Find the probability of each outcome. So the probability of getting a 2, okay? Well, there is 1, 2 out of a total of 8 cards, okay? And then you're going to multiply that by the probability of getting an odd number. Well, there's 1, 2, 3, 4 odd numbers. But since we've already taken out one of the cards, there are only 7 cards left. Okay, so then what we can do is we can cross simplify because 4 and 8 have a common factor of 4. 4 goes into 4 once and 4 goes into 8 twice. And then we would multiply straight across. 1 times 1 is 1. 2 times 7 is 14. So the probability is 1 out of 14. Okay. All right, so then the probability of getting an even number and then an odd number. So the probability of getting an even number, there's 1, 2, 3, 4 even numbers out of a total of 8 cards. And then there are 1, 2, 3, 4 odd numbers. But now since we're not replacing the card, there are only 7 cards. Okay. So we would simplify. 4 over 8 can be simplified to 1/2. And then 4 and 2 have a common factor of 2. 2 goes into 2 once, and 2 goes into 4 twice. So now I can multiply straight across. 1 times 2 is 2, and 1 times 7 is 7. I can't simplify anymore, so my probability is 2 over 7. All right. And then here it says a multiple of 3 and then a multiple of 4. So multiple of 3, there's 1, 2 multiples of 3. Okay, so there's 2 out of 8. Now I'm going to multiply that by the multiples of 4, and there's 1, 2 of them, but now there's only 7 cards. Okay, so then I'm going to see if I can cross simplify, which I can with 2 over 8. 2 goes into 2 once. 2 goes into 8 4 times, and then the 2 and the 4. 2 goes into 2 once, and 2 goes into 4 twice. Then I multiply straight across. 1 times 1 is 1. 2 times 7 is 14. And that is my probability, 1 out of 14. Okay, so hopefully this video was helpful to you. If at At this point of the video, if there's still a couple problems you have questions about, of course, please call, text, email me, or stop by my office hours, and I'll be happy to help you. Okay, you have a great day and good luck on your test.